Okay, hi guys. So in this lecture, we'll be discussing on the characteristic of the E2 reaction which we saw or discussed in the previous lecture. Okay, so let's get started. So we have to discuss the characteristics of E2 reaction. Okay. Okay. So first is that it's a one-step reaction. Okay. Second is obviously that the order or molecularity of this reaction is 2. Don't worry if you are not able to get through the word called order and molecularity. Don't worry that much. I can tell you that by order and molecularity I just mean that if the rate of this uh, reaction is just dependent on two compounds which are nucleophile and the substrate itself. Okay, that is why order or molecularity is 2. Okay, that's just some briefing about it, but for better understanding and more clarity of it, you can watch my physical chemistry lectures. Okay, so then so one important point here is RDS or redetermining step is the stability of the intermediate alkene which is formed, is the stability of intermediate alkene. Okay, then fifth point is obviously that only anti-halides will undergo E2. Only anti-halides will undergo E2. And why am I saying this is, if you look at the mechanism, it's a one-step process in which two bond formation and two bond cleavage process happens at the same time. Hence the base or OH minus or alcoholic KOH which we saw as the reagent must be attacking on if it's attacking on one side, then Br must be living on the anti of the um, alpha or the nearest carbon. So beta Br would be living from the anti position. Okay, it would not be possible if Br and both the base which and the hydrogen on which the base is attacking, if they are on the same side, then this reaction will not take place. Okay, because of steric hindrance, there would be conflict in conflict for the base to actually remove the H plus from the organic compound. And it's, as it is a one step reaction, rearrangement is not possible in this reaction. Okay, and one more thing, that KOH alcoholic which we are using is a base, not nucleophile. Okay, it is extracting H plus ion from the organic compound, hence it is a base, not a nucleophile. Okay, and what I actually mean by the anti rule is that halogen and hydrogen must be anti to each other. I mean that, let's suppose this was the front carbon and this was the back carbon. Okay, this is in presently in staggered configuration, and so OH would be attacking on this and Br would be going from the anti position. Okay, so this is staggered. Okay, and if it's eclipse, then we would be having steric crowding. Just suppose if we have something like this, due to steric crowding reasons, this the nucleophile the base would not be able to attack the hydrogen. Okay, So these two steric hindrance comes into the picture, hence will not take place in this conformation, steric hindrance. Okay, now let's talk about some examples. That suppose these examples are important. Suppose we have something like this. We are already given that CS3 is out of the plane, H is going inside the plane, and Br is coming out of the plane. Then we react it with alcoholic KOH. We would have something like R1. Okay, and on the same side, if we have something like and H is present, this H is, there are two alpha hydrogen which can be present, which one is this and another one is this. And if we have something like this H is going inside the plane, and luckily this Br is also going inside the plane, and this H is coming outside the plane, and we react it with this and we get R2 product, or R2 is the rate of the reaction. So which among the between the R1 and R2 would be greater? Obviously R1 would be greater than R2. Why? Because if you look at the product formed in case of first reaction, we would have something like this. Okay, and in the second case we would have something like this. Okay, so which compound or which alkane is having more number of alpha hydrogen will determine the rate of reaction. So this will be having 3 plus 4, 7 alpha hydrogen, and this would be having 1 plus 2, 3 alpha hydrogen only. Okay, and why did that take place? Because in this case, on this alpha hydrogen, H and Br are syn to each other, whereas in this alpha hydrogen, Br and H are anti to each other, hence double bond will be formed in this between these two carbon atoms. Okay, and we actually made a point in the characteristic of the reaction that the RDS, the stability of RDS is determined on the stability of the intermediate alkene which is formed. Hence, in this case, in the RDS we have more stable alkene than the second case, hence R1 is greater than R2. Okay, so with this we end this lecture, and in the next lecture we'll be seeing some more examples. Till then, good luck and goodbye.